what we're going to transition into now is we're going to take all that chapter 7 stuff we did, all of that cost sort of calculating, analyzing, and we're going to put the revenue piece in with that cost calculation, and we're going to try and figure out how to maximize profit, because that's why you take this class. You take this class so you can figure out how to maximize profit. And so what we start to talk about in chapter 8 is the market structures that you might find yourself operating in when you own a business, run a business, work for a business, manage a business. Knowing the market structure, understanding the structure that your company is operating in is going to make all the difference. Some of this is intuitive. Some of this you would figure out even if you never had a business class, but actually sitting down and educating yourself beforehand is going to make you so much better at your job, no matter what your job is. Okay? We're all going to work for a business, even if it's our own. And so just having the background knowledge of what kind of a structure is this market that we find ourselves in, and how can we react to the things in that market that we don't necessarily have control over, and understanding what we do have control over in order to profit maximize. So chapter 8 is the first market structure. It's the perfectly competitive or perfect competition market structure. It is sort of a baseline, if you will, for market structures. Every market structure that we talk about after this, we will make comparisons back to perfect competition, because it's that comparison that really helps us figure out how we need to tweak what we learn in chapter 8 for those additional market structures. This creates a baseline. I'm going to give you everything you need to know here, and so that when we go on to chapter 9, I can say, do you remember how we did this, this, and this? Well, if we tweak this and we tweak that, we can know everything we need to about this new market structure. And so that's why this one is really so important, is because 80% of what you learn in this market structure will hold true for the others. And so if you get it, then you're already 80% of the way when we get into chapters 9 and 10. Okay? All right. So a market structure is defined by 4 basic characteristics. So there are 4 things I would need to know, or we would need to try and discover about a market in order to identify which market structure it is or is most similar to. I told you really from day 1 in this class that there are exceptions to everything that I tell you, and market structures is no different. But we're gonna talk about this perfectly competitive market structure, which I think some economists would say doesn't actually exist in its purest form. And they might be right? But we're gonna talk about it in its purest form because it creates this baseline for us. And there are markets that are very, very, very similar to this and are closer to this market structure than any other. But first, what we have to do is we have to sort of answer 4 questions or define 4 characteristics that we're looking for to see if a market is a perfectly competitive market, okay? So the first thing we're going to look for is we're going to determine how many suppliers are in that market. Is there 1? Well, that's a very particular type of market. Is there 3? Well, again, that's a different type of market. Is there 100? Is there 1,000? Like, how many suppliers are in the market? Because then I can start to narrow down the market structures that I think we might be in. So, number of suppliers. The second characteristic we need to look for is the product's degree of uniformity. Are we all selling the same thing? Or are we selling very different things? Are we selling slightly differentiated version of about the same? Like, how similar are products from supplier to supplier? That's going to be the second thing we need to figure out. The third characteristic is how easy is it for new suppliers to get into that market, and how easy is it to exit that market? So what does the flow of suppliers in and out of that market look like? That's going to give me another detail that I need. And then the fourth is, how do firms in that market compete? How do firms in that market compete? Do they compete by selling a higher quality product, by advertising, marketing? Like, how do they compete? Is there any competition at all? Do they compete at all? Or if they do, what kind of competition do we typically see? Is it a price competition? What is it? Okay. A firm's decision on how much to produce and the price to charge depends on the structure. It's not really a crapshoot. It's not like you're looking at just the data for your firm, trying to decide what price to charge and what is the profit maximizing quantity of goods to produce. The market that you're in, and particularly the market structure in the market you're in, is actually going to determine some of that for you. Could determine big chunks of that for you, okay? That's why market structure is so important. All right, so perfect competition is our market structure. It's our baseline market structure that we're gonna talk about in this chapter. It's the only one we're gonna talk about in this chapter. So let's go through and talk about those 4 characteristics for perfectly competitive markets. In a perfectly competitive market, we have many sellers. Many, right? Well, how many is many? Well, I actually can't give you a number. I'm gonna tell you it's hundreds to thousands. Could even be, hundreds or thousands, okay? It's so many that producers, sellers get sort of lost in the crowd. The decisions made by one single seller in terms of price or quantity supplied or any of that is so diluted that it doesn't matter. The decision by one seller doesn't matter because they are just a tiny little sliver in the pool of producers or sellers in the market. Now, another tidbit of information that I'm going to give you about perfectly competitive markets is there's also many buyers. Usually when there's many sellers, there's many buyers, not always, okay? But in a perfectly competitive market structure, there's just so many different parties that any one person and the decisions of any one person just gets lost in the crowd, okay? Second characteristic, this was the degree of uniformity one, right? Is that in this particular type of market structure, we're selling a commodity. A commodity is a standardized product. The product is the same. Every seller is selling virtually identical goods that cannot be identified as coming from one producer rather than another producer. That's how the same they are. That's how standard those goods are. What kind of a market, like what kind of a good specifically would be sold in this type of a market? Like, can you think of a good in which you don't say that you can't necessarily identify who the producer is? That you don't discriminate between one brand or the other, or you don't even need a brand at all? Any thoughts? Thank you, Austin. That is one of the best examples. Produce, right? When I walk into a grocery store and I see a pile of apples, I'm not asking the questions like, where was this apple? Maybe I should, I don't know. Where was this apple produced? Who's the producer? Where did it come from? I do not discriminate between those apples. I take the apples and I go, right? Now, if it's an organic apple, that's a slightly different market, you know? I mean, there are special apples, if you will, but I would say your general like supermarket non-organic apple is going to be an example of a perfectly competitive good in a perfectly competitive market. There's just a going price, right? You can't really mark up apples that much and still get people to buy them. They have to be organic if you're going to get a higher price. But a standard run-of-the-mill apple, there's really nothing special about it, right? And so I think any crop would be that same way. Soy, wheat, corn, rice, any of the regular produce at the grocery store. Those are all good examples of perfectly competitive goods, okay? The third thing, and this actually has to do with competition among firms. There isn't any in this particular type of market structure. But that's really what this third sort of comment is alluding to, is that buyers and sellers are fully informed regarding products and resources. So buyers are fully informed about the product and sellers are fully informed about resources. And let me explain what that means. I know walking in to buy a pound of apples, I mean, there's a pretty small range of prices for apples because they're just not that special, right? And if the price is too high here, I'm gonna go someplace else and buy the apples. I am fully informed that most apples are created equal, especially of a certain variety, right, are created equal, and that the price has to fall within some reasonable range, right? And so that's what the buyers being fully informed about the product is. Nobody needs to advertise to me. And you don't see any advertising for apples, like a certain brand of apple coming from a certain farm, because there's no reason to spend the money, right? And that sellers are fully informed about resources. People who produce apples are using generally the same resources to grow the apples. And those have a pretty similar price associated with those resources. It's land in good growing regions. I mean, they grow lots of apples in the Northwest, right? I mean, that land, that orchard land is gonna come at probably some pretty standard price. You have to buy your little saplings to start growing your trees. I mean, you have to, if you do use pesticides, that's gonna come at a pretty standard price. So in other words, like there's just not gonna be much competition among firms because there just doesn't need to be. It doesn't actually get you more business if you advertise or market or compete, okay? It actually costs you money and doesn't really make you any more money. This fourth one, firms and resources are mobile. This is about going in and out of markets, that ease of entry and exit. This is basically saying in this type of a market structure, we would be able to say that firms could get out of the apple growing market or get into the apple growing market pretty easily. They're pretty mobile. It would be pretty easy for a firm to get in or leave on their own decision, okay? All right, so now let's talk about demand under perfect competition. So this is pretty particular to this market structure. We know that when we have a market, we have upward sloping supply, downward sloping demand, and we have this equilibrium point, right? And that determines what the market equilibrium price or the market clearing price is for that good. What this is saying here is that the market determines the price. So we have that upward sloping supply, downward sloping demand, right? And it reaches an equilibrium, and that determines the market price for that apple, right? And that as an apple supplier, as an apple producer, if I decide to price my apples above that equilibrium, I'm probably not going to sell many apples, if any at all. I have pretty much put myself in a situation where I have to accept the price that the market has given me for my apples. So that equilibrium, wherever it is, if I want to supply apples, I pretty much have to supply them at that price. So while the demand curve for the whole market for apples is downward sloping, the market for me, the market I use when I'm doing my analysis is a perfectly horizontal, perfectly elastic right? You've seen that demand curve before back in chapter 5 when we talked about those special elasticity demand curves, right? Perfectly inelastic, unit elastic, elastic. This is the perfectly elastic one. This is where it comes back around, okay? That as a firm, I have to basically adopt a perfectly elastic horizontal demand curve at whatever that market equilibrium price is determined to be. I am, in this type of a market structure, I am what they call a price taker. I don't get to make a price, I have to take a price because the price is determined for me. So price takers have two options: take it or leave it. Stay in the market and accept the price that the market has told you you get, or get out of the market and go enter a new market, whatever. It's a take it or leave it situation. There's no competition among firms because the price is basically set. You can't really get a higher price for your apple. And why would you take a lower price, right? And that's what that perfectly elastic demand curve alludes to, right? It's perfectly elastic because consumers would be perfectly responsive to an increase in price. You try and increase the price of that apple, demand is going to basically go to zero. And why would you lower your price? It's this type of market structure really lends itself to a singular price that's determined by the market. Any questions about that? Okay, so here's the visual, okay? Here we're talking about wheat, okay, bushels of wheat. Here is the market for wheat, is this first graph here. You can see upward sloping supply curve, downward sloping demand curve, exactly what we would expect to see in a typical market. And it has an equilibrium price per bushel of $5. The demand curve facing our firm would be a perfectly horizontal demand curve at whatever that equilibrium price is. We're differentiating between market demand and firm demand, and that's an important thing to do in this particular type of market structure. Any questions? This is a very, very important detail about this type of market structure. Okay, don't overthink this. Don't overthink this. This visual says it all, okay? All right, so let's switch gears and start talking about profit maximization really for the first time in this class. But we won't stop talking about it for weeks, okay? Economic profit, you already know the definition of economic profit. We talked about it in chapter 7, but economic profit is revenue or the money coming in minus both your explicit and your implicit costs. So both those like accounting costs and those opportunity costs. Firms maximize profit by determining the quantity at which total revenue exceeds total cost by the greatest amount. From this point on, if the word profit comes up, you can assume I'm talking about economic profit, okay? Because in this class, there is no other type, all right? All that is saying is that total revenue minus total cost, right, gives you profit. And so you're just trying to find the place where total revenue exceeds total cost by the greatest amount, so that when you subtract them, it gives you profit. And this is going to become important when we look at graphs and we're trying to visualize this, right? Because while you could just do this as a straight calculation, why would you do it that way? Why wouldn't you put it on a graph, right? Just kidding, but that's what we're going to do. We're going to put it on a graph, okay? So you can see that the higher this number is and the lower this number is, when you take the difference, right, this becomes greater. And we want to find the place where it is the greatest, where profit is maximized, okay? In a perfectly competitive market structure, firms do not get to pick their price that they're going to sell their good at. They don't, we just said that, They have to accept. They are price takers. The only thing a firm in a perfectly competitive market structure gets to decide is what quantity they're going to produce and sell at that price. Now, obviously, they're going to try and find the quantity that maximizes profit, right? That gets this number as high as possible. And that's the process we're going to begin to talk through now, okay? All right, this chart, it's going to make your eyes roll back in your head. Just hang in there. You've seen a lot of this before, and the stuff you haven't seen before isn't that hard, okay? So we're still continuing on with that example, that wheat, that bushel of wheat, okay? We're looking at information pertaining to a singular firm in that wheat market. So you can see here in column 1 is just the numbers 0 through 16. We could keep going. We don't need to, okay? And you'll see that here in a minute. And then the second column here is marginal revenue. Now, you haven't seen marginal revenue before, but what you are going to learn is it's the other piece that you need to determine profit maximization. Besides marginal cost, marginal revenue is that other piece that you need. Marginal revenue, what is the change in revenue? What is the additional revenue when we sell each subsequent additional unit of our good? Well, the market already told us our price was 5. And so what's the additional money coming in the door every time I sell another bushel of wheat? Well, it's $5. And so you can see there is a 5 all the way down. No mystery here, right? Your marginal revenue is equal to your price in this particular case, because you're getting the same price no matter how much you're selling, okay? Total revenue is just how many are you selling and what price are you selling them at, and multiplying the two together. What's the total you're bringing in? So you can see 1 times 5 gives you 5, 2 times 5 gives you 10, 3 times 5 gives you 15, so on and so forth. What's the total in the cash register at the end of the day, right? Once you've collected all of that revenue. Total cost, in this case, has been just given to you. Now, if I gave you variable and fixed, you could calculate total, right? In this case, I've just given you total. Can anybody tell me what the fixed cost is, though? By looking at the total, can you tell me? What is fixed cost in this case? Thank you, Powell. It's 15. How did Powell know that? He knew that because he looked to see what total cost was when we were producing nothing, which meant we had no variable cost. We just had fixed. So I know that $15 of this total is fixed and the other is variable. So if I needed to back out of total and find fixed and variable, we could do that too. It's important to understand how all of these numbers work together. Your marginal cost, you calculated this in your worksheet on Friday, right? It is the change in total cost divided by the change in quantity. Well, this is easy. The change in quantity is 1. So you find the change in the total cost and divide it by 1 every time, no problem, okay? So when we go from producing 0 units to 1 unit, we go from a total cost of 15 to 1975. The change in total cost is 475. As we go from unit 1 to 2, we go from 1975 to 2350, or a marginal cost of 375. It's easy. You've done this, right? And if you look down this column and see these numbers, they look exactly like we expect them to, right? Because we graphed them and we know what the curve looked like. It looked like a check mark. So our numbers went down, went back up, and then went up further than where we started. So it created that check mark that I told you should be looking for, okay? Looks exactly, those numbers fall in line, exactly how we would expect them to. Those look good, okay? Average total cost, well, how'd you calculate and graph this too? You took your total cost In this case, what was in column number 4, you divided it by your quantity, which was in column number 1, and you came up with your ATC, your average total cost. And we know that that's pretty U-shaped in the end, right? Here, we didn't quite go high enough to see it come back up all the way to its proper U, but we can see that it follows that trend, right? It goes down, and then it comes back up. Okay, had we gone on and done 17, 18, 19, 20, we would have seen that it would have created a full U for us. And then your economic profit or loss, this is a new column, but we know how to calculate this, right? We take the total revenue, which is in column 3, we subtract the total cost, which is in column 4, and we get our profit or loss, as the case may be, okay? So we see that we experience a loss because 0 minus 15 gives us negative 15. 5 minus 1975 gives us a negative 1475. We can see that we experience losses. Those losses go down. We begin to see a profit. We actually get to some peak with our profit, and it begins to taper off again. This is a function of those costs. Remember, our costs are getting lower. When your costs get lower, your profit gets higher. When your cost per unit gets lower, your profit per unit gets higher, right? Because your marginal revenue is staying the same. So your $5 is staying the same. And as you drive down that cost per unit, you're able to experience more profit. But then remember, that always changes. Those costs always go back up. That's the U-shape. They go down and go back up, go down and go back up, which means your profit goes up and goes back down. Okay. You can see here at this bolded line that we profit maximize. Our profit is the highest at 12 units of production. It is a coincidence that it is 12 units and $12. That is simply a coincidence. Don't let that throw you off at all. We'll come back to this depending on how much time we have. I want to skip a couple slides and then come back, okay? Let's talk about something we call the golden rule of profit maximization. We know that where the greatest distance between these two things is, we're going to find the greatest profit. But when we are talking about looking at our per unit or marginal numbers, there is a very, very specific way to find the actual quantity that you profit maximize the second you look at a graph. And that's what we're going to learn, okay? If you look down here at the bottom at this golden rule of profit maximization, there's probably no more important thing to memorize in this entire class as a whole than this right here. It is the golden rule. It always holds true. No matter what market structure we're talking about, right? No matter what the numbers look like, this is true. Firms find their profit maximizing quantities, their profit maximizing level of production, where marginal revenue equals marginal cost. We're going to graph marginal revenue. You already graphed marginal cost. It is the physical intersection of those two lines on a graph that helps you go down to the x-axis and identify the quantity you should produce in order to find that profit maximizing level of production. I made the mistake many years ago of implying that you should all go get tattoos that say MR equals MC, because that's how I refer to this, right? MR equals MC. And then someone did it. So I'm not going to joke about that anymore. But there is no reason why this shouldn't be in big, bold letters on your, notes for the exam, very first thing on your notes, MR equals MC. That is your profit maximizing condition. Okay? Is it extra credit if you get a tattoo? I don't know, man. I still owe her parents an apology. I don't want to have to do that again. No extra credit. Extra credit if you don't. Okay, so let's begin to go back and look at our numbers, okay? Let's go back to where we were. And let's look at marginal revenue and marginal cost. Now, when we look at them, you're going to say, Baca, those aren't equal. You're right. They'd be equal. You'd find this point of intersection on a graph. Here we're looking at the raw data, so bear with me, okay? So if we look back at that bolded line, we find marginal revenue of 5, and we find marginal cost of 475. They're not equal. It actually is really hard to find a place where these numbers would be exactly equal when you're just looking at all of this data. The chances that it's going to work out that way aren't that good. But if you can imagine it on a graph, okay, let's look what happens when you increase to one more, above and beyond 12. You can see that the additional money you would be bringing in from unit number 13 is $5. The additional cost you would be spending to produce unit number 13 is $650. If you just read across. Why would you produce something that cost you $650 if you knew that you would only be able to sell it for $5? That doesn't make good business sense, does it? So basically, another way of saying MR equals MC is you produce up until your marginal cost is greater than your marginal revenue. You would find a point of intersection on a graph, and you would find it at about 12 units. Because when you got to 13 units, you would be able to see distinctly on the graph that your MC, your marginal cost, was greater than your marginal revenue. So you'd want to stop. So if this point of intersection happens on a graph between 2 units, between unit number 12 and unit number 13, you want to round down. Because you never want to get to the unit in which the cost is higher than the revenue. And you'll see, when we start to look at the graph, you'll see what I mean, okay? All right, so let's take a look at that graph really quick. Okay, let's look at the top first, and then we'll look at the bottom. When we look at the top, what we're looking at is our total numbers. We're looking at this calculation right here. We're not looking at this, we're looking at this. You cannot take your totals and mix them with your per unit numbers, your averages, your marginals. You can't put that all on the same graph. They just aren't the same numbers. You really can't compare anything. It's like comparing apples and oranges. Like, it doesn't make sense. So what we need to do is we need to put our totals on one graph, and we can do an analysis that way, or we put all of our per units, our marginals, our averages on one graph, and we can analyze that way. Now, your marginals, your averages, your per unit numbers, that's what you did on Friday with your worksheet. That's the graph we like to use in econ. The totals just don't give you nearly enough, or the kind of sort of nitty-gritty sort of per unit information that we like to see. And so that's the way we're going to look at it, and that's the way I'm going to test you, is I'm going to be looking for your understanding primarily of those per unit and marginal numbers on that graph. This first graph, there's good stuff here, right? And it's an interesting comparison to make. What I did here is I took your total revenue and your total cost and I graphed them. So if we go back here, right, that's 3 and 4. I graphed column 3 and column 4 at these different quantities. The quantity is along the x-axis. The total dollars is along the y-axis. And so this yellow line here is total revenue because it's consistent, right? It goes up 5 every time, so it has a constant slope. And then we have our total cost curve, which starts at 15, right? Starts at our fixed cost when we are producing 0. And you can see that it remains above total revenue for some span, then it drops below, and then it goes back above. Well, if you look back at the chart, right, this is when we have negative profit or a loss, is when the cost is greater than the revenue. When it's costing us more to make the stuff than we're getting when we sell it, that's our loss. It is this point at which we dip down and see costs fall and sit beneath revenue. This is our positive profit is in there. And then it goes negative again, which if you go back, you see that's what happens, right? You end up with these pretty significant losses, and then you see profits, right? As the costs dip lower and lower below, and then it goes negative again, okay? That's what happens. That's what happens because of increasing marginal returns, diminishing marginal returns, all that stuff we already talked about, okay? So it is in this span that we are going to, even if it hadn't been marked for us, it is in this span that we are going to find our greatest profit, our profit maximizing point. And we would do that by finding the greatest physical, vertical, perfectly vertical distance between those two lines, curves, whatever, okay? The greatest vertical distance. It's like finding the greatest difference here, except for you're finding it physically instead of mathematically, okay? So if you can find the greatest physical distance, you will also find the greatest mathematical distance because all we've done is graph the numbers. So the math is like built in, okay? And so you will see that we find that at 12 units. And if we trace horizontally from that greatest vertical distance, you will see that we have a total revenue of 60 and a total cost of 48, giving us our maximum economic profit of $12. Now, you know where that came from. It came from right here. Here's that same 60, here's that 48, and the difference is 12, okay? It's just the physical representation of all of this data, okay? Or, I'm sorry, those two columns, 3 and 4. The other graph is gonna be the rest of it, okay? But you can see we have our quantities down here. Any questions about that? I like this multiple choice question too. You know, how do you find profit maximization on a graph with totals? Well, you find the greatest vertical distance between total revenue and total cost, and that will give you the point of greatest revenue. Any questions about that graph?
So for the first graph, how would you apply the golden rule here?
You wouldn't. You
Okay.
wouldn't. You can't. You have to have your marginal numbers in order to be able to do that, and there aren't marginals on that first graph.
Okay, okay.
So it's a great question. So just hang on to that, and when we do the graph below it, which is the graph you're gonna see over and over and over again in this class, this top one, not gonna see it that much. This bottom one is the one you're gonna learn to love or you're gonna learn to hate. That's a great question, Ben. You couldn't do it up there. This just shows you this, but the second graph is gonna be the golden rule. Thank you, great question. All right, so let's look at this one. Let's look at this bottom graph, okay? So we have a couple of curves that should be familiar to you because you graphed them on Friday, and those were our chapter 7 curves, right? This red guy here is going to be your ATC, or average total cost curve. That's U-shaped. That is simply the data from the chart with all the numbers. We just graphed it. You know how to do that. You did it, okay? And then this yellow is our MC, our marginal cost curve. It's that check mark, right? That's going to intersect our ATC and our AVC. We don't need our AVC on here. We'll use it for other purposes later, but for this, we don't need it, okay? So you know those two curves. Then we have this perfectly horizontal line, blue line, at $5. Well, you've seen that before. That was our firm's demand curve, not the market demand curve, our firm's demand curve, right? It is also equal to marginal revenue. Our marginal revenue, remember, was $5. No matter what the quantity was, it was $5. And so not only is that our demand curve, it also is our marginal revenue curve or line. Okay, I'll call them curves a lot because in reality, they probably have a curve to them. But in this case, it looks like a line. It's also equal to our average revenue. Now, average revenue becomes important more in later market structures than in our this current market structure. But this is sort of introducing you to these concepts. Average revenue. Well, it's an average. We didn't calculate it before, but it's easy in this particular case. If you take your total revenue and divide by your quantity, it's going to give you 5 every single time. Because your marginal revenue was 5, your average revenue is also going to be 5. Okay? Because your revenue is the same all the time. Okay? Don't overthink that. This is just me like planting a little seed in your head that there's this thing called average revenue out there that might become important. Okay? So we have this one line that actually represents a lot of different things. Demand, marginal revenue, and average revenue if you needed it. Okay? If we find where marginal revenue equals marginal cost on this graph, we will find our profit maximizing quantity of production. That's all you find with this. All you're going to find by finding this intersection on this graph is your profit maximizing quantity of production. Quantity, that's all you find. That's all this is good for, but it gives you everything to get you started on finding all of that good profit maximizing information. So MR equals MC up here, right at point E, where the yellow and the blue intersect. Your MR is the blue, your MC is the yellow. You have this point of intersection. If you were to then travel perfectly vertically down to your x-axis, which holds your quantities on it, you would be able to see that 12 units was your profit maximizing quantity. Well, you actually already knew that because you saw this chart, okay? And we talked about it. And then we looked at the graph on the top and we talked about it. But if you have nothing except for this bottom graph, you still can find all the information that you need. So MR equals MC, travel down to your x-axis, which has your quantity on it, and locate your profit maximizing quantity. How do I calculate my profit? I now have a quantity. Once you have your profit maximizing quantity, once you know what it is, the only information you care about is the information that exists along that plane, if you will, for that quantity. So I now no longer care about anything on this graph except for the information that sits along that perfectly vertical dashed line at 12 units. Why would I want to produce a quantity that wasn't profit maximizing? Doesn't make any sense, okay? So what I would do next is I now know how much I'm getting per unit, right? I know I'm gonna produce 12, I know that. I know how much I'm getting because that's actually on my demand curve, right? I'm getting $5 per unit. Now I need to be able to subtract my cost per unit to see what my profit per unit would be. So if I, along that same plane, there at 12, if I travel down to my ATC, which is there at point A, that's actually going to be the average total cost per unit, which is $4, subtracted from my marginal revenue, my price per unit of 5. That gives me a $1 per unit profit times 12 units sold gives you $12 in profit. The same exact number that we got on the previous graph when we talked about totals, but this is us just analyzing on a per unit marginal average, sort of using that information on that sort of a graph. We can find exactly the same stuff, but perhaps we even get a finer picture of what's going on. I know I've gone a minute over. Is there any questions?